Hello. Today's lesson we're going to bring together the work we've done on particles and how it relates to the density of materials. Firstly, this is what you need to know from the syllabus. So if you copy the heading into your books, density of materials, and then on the next couple of slides I'm going to go through how to log in using Focus eLearning. So once you've read this slide, you might want to get another device, pause the video a bit, so that you can use that extra device to go through logging into Focus eLearning whilst I'm going through it on the video. So if you're watching this on your mobile phone, maybe get a tablet or vice versa. I'm going to show you now how to log in to Focus eLearning. So if you search for Focus eLearning, so if you just put the address in there, Focus eLearning, it will come up on your computer, whatever you're using. And everyone's got the same username, student@Bishop Challoner355. Password's hidden there, but it's here. So it's all lowercase, WY4I4GSWY. So if you'd like to pause the video now and maybe write that down, keep it somewhere safe. So your username, student@Bishop Challoner355, and the password.
Okay, so once you've logged in, you'll get this page coming up, and there are more options down here, but just to make it easier, I've just concentrated on the top 8. You're going to log in here, but equally you could be using it for your chemistry required practicals or your biology required practicals. It's a really good learning resource, especially here. Look, we've got the new physics specification of learning those equations. So we need to click on here, physics required practical, to get to the next window. The next thing you'll see is a list of all the different exam boards. And we're going to click here because ours is AQA. When you've done that, you'll see a list here of all the different physics required practicals. And we are going to be looking at this one, density. So click on the density. So for density, you need to know how to measure the density of a regular block, a regular shape, irregular shape, and a liquid. So a regular block would be something like a cube or a cuboid. Irregular solid would be a piece of rock or a small statue or something like that. And liquid, you'll have different options of different liquids like water, oil, salt water. So let's look at regular block first, and as you can see here we've got a smaller representation of a larger block here. You're going to use the ruler to measure the sides, and you need to measure the 3 sides of the height, the width and the length, and then to multiply them to get to the volume. So if you click on the ruler, that will help you move the ruler to measure the sides. If you click on the big block here, that will enable you to move the orientation of the block so you can measure the length of a different side. You've got 2 options. You can change the size of the block or the material the block is made out of. I would keep the block size the same, and I would change the materials, so copper, lead, polystyrene. So they're the different variables that are going to go into your results table, what the block is made out of. So you need to measure also the mass of the block. Now here they use weight, or weigh the block. I don't really like that. They should use mass really. So in your results table, don't write weight, write mass. And your mass for this, because it's a small shape, is in grams. But also for larger shapes we would use kilograms. If you've got some plasticine, you can actually do this at home. So plasticine or Play-Doh, or different shapes like dice, sugar cube, as long as they're a regular shape, so a picture frame, box of tissues, that sort of thing, a book. Use a ruler to measure the 3 different sides, then use that to get the volume. And then if you've got some kitchen scales, you can use those to measure the mass. And again, just worked out some simple shapes here. This QR code here, if you scan that with your phone, it will take you directly to the Focus e-learning site, and I've put a lot of those onto previous PowerPoint presentations. So now you need to go back to this window here, and you need to click on irregular solids, because we've looked at a regular shape. Now we need to look at an irregular shape. Okay, so to measure the density of an irregular solid, as you can see, this is a piece of rock here, and it's not easy to measure the volume with a ruler. So we're going to have to use something called displacement. So we use a displacement can, or a Eureka can. There's a picture of one here. So it's filled up with water there, and then there's a spout here. So when you put that object, rock or a small statue, into the water, it will push out a volume of liquid. Well, we're going to use water because water's got a density of 1, so the volume that is pushed out into the measuring cylinder will be the same as the volume of this object. So this uses Archimedes' principle on displacement. You can use this principle at home in your kitchen as well. You can get just a glass and fill it up with water, and then put an irregular object in there. It's got to be something that's going to sink. Okay, so put the object in there, and then you need to catch the water that comes out in a measuring jug or a measuring cylinder if you've got one, and then of course you can use your kitchen scales to measure the mass. So it might get a bit messy, so I suggest you put some kitchen roll round and don't use a dirty rock or anything like that from the garden. So next you need to get back to this window here, and then click on liquids to start recording your results for density of different liquids. So this will come up, and here are the instructions here. So you measure the mass of the empty cylinder and then choose a liquid. So that's weigh empty, and then add the liquid, and this one is water. So you add a certain volume of liquid, and then make it easy, so go up in tens, and then record the mass of each volume. So repeat that for a couple of different volumes of liquid, and then repeat steps 1 to 3 with a different liquid. So you start off with water, and then you can choose alcohol or salt, and then salt solution. Before we go on to the next slide, I want you to pause the video and see if you can remember the equation for measuring density of objects. So if you pause and write the equation down. Okay, so here's the equation for calculating density. So you measure the mass, you measure the volume and divide the mass by the volume to find the density of an object. This P here, like an italic P, is the Greek letter rho, and that's what we represent density in equations. M for mass, V for volume. So you've got your triangle here, and so remember, whatever you want to find out, you cover up. So maybe cover up density, and it tells you mass divided by volume. Or if you want to find volume, it tells you mass divided by density, etc. And these two you multiply to find the mass. You probably would get something a bit less straightforward than just finding out the density. They might ask you to find the mass or the volume, so it's very important to try and remember either the triangle or your equation. Units are also important to get correct. Your standard unit for mass is kilograms, and for volume is cubic meters, but we've been using small objects, so the mass is grams or cubic centimeters. The unit of density is your mass divided by the volume. So this will help you. If you can maybe remember the units of density, that will help you in deciding what you're going to measure and what you're going to do in the equation. So you measure the mass in kilograms and you divide it. This slash line here is a divide by the volume. Before we go on to the next slide, I want you to have a think about what headings you'd put in your table of results. So if you write the headings down on a piece of rough paper, and then we'll go on to the next slide and have a look. Okay, so your results table to calculate the density. Here's going to be your objects, so your solid objects, copper, aluminium, polystyrene, the liquid, the oil, the water, and your irregular objects like rock or small statue. Everything's going to have mass, so everything's going to be filled out for those columns, that column there. These three columns here, you're only going to fill out for regular solids, okay? Because as we discussed before, you can't measure the length or width, height of a piece of rock with a ruler. You're going to have to use displacement to work out the volume. So for irregular solids and liquids, you'll just have this column filled in, and so you divide the mass by the volume to fill in this column here, the density. Once again, this QR code will link you directly to the Focus e-learning site. So some review questions here to think about density, and not just recall how to find density of an object or what is density, using particle theory to explain density and explain, the properties of solids, liquids and gases. How do you measure the density of an object that floats? That's something to think about. How do you measure the density of liquid? Well, we've just done that one. So again, pause the slide and have a think about answering, or what sort of answer do you put for those questions. A final thing that you might want to have a look at is having a go at a past paper question. So this one is the statement at the beginning of the question. The student wants to calculate the density of the two objects shown in the diagram below. So you've got a metal cube here, which is going to be your regular shape, and a small statue here, which is going to be your irregular shape. So describe the methods that students could use to calculate the densities of the two objects. So if you pause the video now and have a go at writing your answer, it's a 6 marker, so 6 sentences to answer how you would go about doing that experiment. Okay, so this here is just what the examiners get, and as you can see, to get the full marks it says a clear and coherent description, steps are logically ordered, and somebody else will be able to obtain valid results. So it's reproducible. Okay, if you just can remember a few things like measure the mass using a balance, so you get 1 or 2 marks, but it's basically to get the full marks you've got to have an indication that you know about mass, how to measure the mass, how to measure the volume, how to calculate density, and the difference between the two methods of a regular and irregular solid. So here is the mark scheme. Indicative just means that what whoever's marking your exam, or me, if it was me marking your work, would be looking for. Again, think back, it did say a clear and coherent description. If you're struggling writing long sentences, just write bullet points, that's fine, as long as it's in a logical order, and it's just like writing a recipe, so somebody else can do it. Okay, so again, tips for answering these questions: you're measuring something, okay, measure the mass, that's fine, but you've got to say what do you use, because you wouldn't get a mark otherwise unless you say measure the mass using a balance, measure the length using a ruler. Immerse in water means put the object right in the water, and again they're using displaced here. They haven't actually used Eureka Can, but to get your mark you've got to associate with the volume of water displaced is the same as the volume of the small statue. And again, once again, for your physics required practicals, use the equation, so you'll get a mark for writing down the equation, telling the examiner that you know how to calculate density. So green pen your work now and check that you've got 6 marks. A couple for how to measure the mass, how to measure the volume, using displacement, and also using the equation.